So let's solve some problems with the zero factor theorem. What is the zero factor theorem? The zero factor theorem says if you have a product and that product is equal to 0, then one of the pieces in the product has to be 0. Well, why is that true? 0 times 7 is 0. 7 times 0 is 0. Any number times 0 gives you 0. The only way to get an answer that is 0 that came from multiplying several things is if one of those things was 0. So our strategy is to move all terms to one side of the equation. We end up with an expression equal to 0. Then we factor it. If you need some help factoring, we have other videos on that. And then set each factor equal to 0 and solve. So let's do an example. Solve x plus 4 times x minus 7 equals 0. Do you see we have a product? Okay, so what we're going to do is we're going to take each piece individually and set it equal to 0. So x plus 4 equals 0, or the second piece equals 0. And then we solve these. Subtract 4 from both sides. So we see x equals negative 4. Add 7 to both sides. That way x is all by itself. When we do that, we see x equals 7. So our answers are x equals negative 4 or x equals 7. And you can start to do this quickly in your head. X plus 4 equals 0. That means x equals negative 4. Think about just subtracting that. X minus 7, we add the 7. Okay, let's do another one. Solve. This is a product. X minus 10 times x minus 8 equals 0. So we have two things multiplied together. The answer is 0. That means one of those pieces has to be 0. So x minus 10 is 0, or x minus 8 is 0. If you want to write the parentheses the first step, you can. It's not necessary. You can go straight to this step. Then we're going to add 10 to both sides here. That way we have x all by itself. Then we end up with x equals 10. Over here, you have x minus 8. If you want x all by itself, you would add 8 to both sides. Then you end up with x equals 8. So these are your answers. And again, just look at it. X minus 10. So move the 10 over. You're adding 10. So 10 minus 10 is 0. Same thing here. X equals 8. I want to point out one thing before we continue. Notice I wrote the word or in between. There are two values that make this expression equal to 0. So if you plug back in, plug x equals 10 back into the equation, 10 minus 10 times 10 minus 8. So what I've done is replace this x and this x with a 10. Well, 10 minus 10 is 0, and this is a 2. So 0 times 2 is 0. This doesn't say that both pieces in the product are going to be 0. One of them will be 0, and then 0 times something non-zero is still 0. So try the other one. Plug x equals 8 back into the equation. 8 minus 10 times 8 minus 8. 8 minus 10 is negative 2. 8 minus 8 is 0. In this case, we still get 0. But again, I want to stress, these answers each give one place where one set of parentheses is equal to 0. If you plug in 10, one part's 0, the other one is not, and that's okay. So let's do another one. Solve 3x minus 19 times 2x plus 5 equals 0. So this one's a little more interesting. We're still going to do the same thing. We're going to set each piece equal to 0. So 3x minus 19, that's the first piece in the product, equals 0, or 2x plus 5, the second piece in the product, equals 0. Then we're going to add 19 to both sides. We end up with 3x equals 19. We want the coefficient of x to be 1, so we divide both sides by 3. So x equals 19 over 3. Let's do this one. 2x plus 5 equals 0. So subtract 5 from both sides because you want the 2x term to be all by itself. So you get 2x equals negative 5. We want the coefficient of x to be 1. So divide both sides by 2. X equals negative 5 halves. These are your two answers. Let's look at how you can do this quickly. 3x minus 19 equals 0. So if you just look at this place where it's factored, you're always going to take the opposite sign of the number in the back, and you're going to divide by the coefficient. So do you see this becomes a positive 19 divided by 3? And that's what we have. Same thing here. The opposite sign, so 2x plus 5, make this a negative 5 and divide by 2. You're doing 2 steps in once in your head. Let's do another one. This example has 3 pieces multiplied together. We still have a product, but now we have 3 things. So let's tweak the zero factor theorem. Now we have if A times B times C equals 0, then one of those pieces is 0. Either A is 0, or B is 0, or C is 0. Again, because 0 times anything that's not 0 gives you an answer of 0. So we're going to set each piece individually equal to 0. Okay, this one's done. X equals 0. Then we solve them individually. So when we do this, we get 2x equals 1. We want the coefficient of x to be 1, so we divide both sides by 2. So we get x equals 1/2. And then we do the third piece. X plus 5 equals 0. Subtract 5 from both sides. So we end up with x equals negative 5. So in this case, we have 3 options. X equals 0, or x equals 1/2, or x equals negative 5. Let's solve some more. Solve 5x equals 0. And you may be wondering why I wrote this one down. Because the way to solve this is to divide both sides by 5, right? So when you divide both sides by 5, you get x equals 0 over 5, which is just 0. So x is 0. The reason I put this here is because a lot of students are concerned because I say, well, this is really 5 times x equals 0. And if we use the zero factor theorem, then we see that 5 is 0 or x is 0. Well, there's this key word here, or. 5 is not equal to 0, so that one isn't the answer. This is the only option. Okay, so let's look at this one as well. Solve 3 times x plus 2 equals 0. So all you really have to worry about being equal to 0 is this x plus 2, right? Because you could think about dividing both sides by 3. So x plus 2 equals 0 over 3, or x plus 2 equals 0. So x equals negative 2. Or you could say 3 times x plus 2 equals 0. So if you want to use the zero factor theorem, you certainly can. 3 is 0, or x plus 2 is equal to 0. But we see this one's not true. So this has to be the answer. Let's add one more piece. 3 times x plus 4 times x plus 2 equals 0. Well then, 3 is equal to 0, or x plus 4 is equal to 0, or x plus 2 is equal to 0. Again, this one isn't going to work. So these are your answer choices. Okay? So, but another way to think about it is if you don't want to use the zero factor theorem and have to mess with the 3, divide both sides by 3. So if you get really good at this, when you do a whole bunch of these, you're going to get really comfortable and you're going to say, okay, well, this is just a constant. These 2 pieces with my variable are the only pieces I need to solve to what value of x we should have to get equal to 0. So you're really always solving this, if that makes sense. So let me show you one more. 4 times x plus 7 times 3x minus 5 equals 0. You don't even consider the 4, right? You set this piece equal to 0, so you see x equals negative 7. And you set this piece equal to 0. Let's do it quickly in our heads like we've been practicing. You take the opposite sign of the 5, so you get a positive 5. And the coefficient of x is 3, so you divide by 3. Does that make sense? Okay, let's try another one. Solve x squared minus 8x equals 0. So to use the zero factor theorem, we have to have a product, right? So we need to factor this. We're going to factor out the greatest common factor out of both terms, and that's an x. So we get x times x minus 8 equals 0, and then this is easy. These are the problems we've been doing. So x is 0, or x minus 8 is 0. So we see x is 0, or x is 8. Okay, and that brings us to this question. Solve x times x plus 2 equals 24. We've done a whole bunch of these. So some of you may be tempted to do something crazy. X equals 24, or x plus 2 equals 24. So this is an answer. So then x equals, we subtract 2 from both sides. X equals 22, right? That's what we've been doing, isn't it? No, don't you dare do that. Let's check it. That would be like 24 times 24 plus 2 is equal to 24. So 24 times 26, that's not equal to 24. And you could check the 22 as well. Maybe that feels like what you've been doing, but you should be very, very, very careful. The reason the zero factor theorem works is that you have two things multiplied together and you get an answer of 0. Well, this is true. The reason this works is because 0 times another number is 0. And some number other than 0 times 0 is 0. If the numbers are finite, if you multiply by 0, you get 0. So let's go back and look at this one. X times x plus 2 equals 24. Well, how many things can we multiply together to get 24? Well, you can do 1 and 24. I'm looking at two different numbers, right? 1 and 24. You could do 2 and 12. You could do 3 and 8, 4 and 6. Those are the integer multiples. Okay? You could do 48 and 1/2. Doesn't that give you 24? So there's really lots of things that we can multiply together to get 24. So we can't just say one of them has to be 24. Which if you have a times b equals 0, one of the numbers has to be 0 for this to be true. That's not true in this case. So how do you handle this? Well, here you're going to distribute and you're going to clean it up with algebra. You're going to distribute x times x and x times positive 2. So x squared plus 2x equals 24. We're going to move everything to one side of the equal sign. So x squared plus 2x minus 24 equals 0. So we're looking for all the factors of 24. We've written them all out here. I'm going to look at integer factors, so I'm not going to worry about that one. All of the integer factors, natural number factors of 24. I'm going to find one that when I subtract, I get a positive 2. Remember, third sign negative, it tells us signs inside the parentheses are going to be different. And we're going to subtract the factors of the last term, in this case, to get the middle term, okay? And then the bigger factor gets the sign of the middle term, okay? So signs inside the parentheses, when we actually get our final answer, are going to be different. We're going to subtract these factors right here to get the middle term, to get a positive 2. And then the bigger factor gets the sign of the middle term. Well, our middle term is positive, so the bigger factor gets a plus. And we're going to subtract, which means that, and we said the signs were different. So which of those, when you combine them, it gives you positive 2. So negative 1 plus 24, that's 23, because you're doing 24 minus 1, really. Negative 2 plus 12 is going to be 10. Negative 3 plus 8 is 5. Negative 4 plus 6 is 2. So we're going to use these. So you can write this as a polynomial with 4 terms, x squared minus 4x plus 6x minus 24 equals 0. You can factor by grouping if you want to. Group the first 2 together and group the back 2 together. So you factor out the greatest common factor, x, so x minus 4. You factor out the greatest common factor of the back, you factor out 6. So you get x minus 4 equals 0. And x minus 4 is a factor of both, so we're going to rewrite it. And then you can read off the rest, and that's the other factor. So before we actually finish solving, you see that signs inside the parentheses end up being different. If your lead coefficient is a 1, then these numbers are the numbers that just go in the back of the parentheses. So use an x minus 4 and an x plus 6. Anyway, this is how it factors. Then we're going to use the zero factor theorem from here. So x minus 4 is 0, or x plus 6 is 0. So x is equal to 4. Or x is equal to negative 6. These are the answers. Plug them in. 4 in place of here. So you'd have 4 times 4 plus 2. Do we get 24? Let's check it. 4, well, this is a 6. So 4 times 6 is 24. That one works. Perfect. Check the other one. Negative 6 times negative 6 plus 2. Is that one equal to 24? We get a negative 6 times a negative 4. Negative 6 times a negative 4, negative times a negative gives us a positive, and 6 times 4 is 24. That one works. Does that make sense? You're not allowed to just set each piece equal to this number unless the number is 0. Okay? Otherwise, you move everything to one side, and you factor, and then use the zero factor theorem.